Okay, we're continuing our work with logarithms, but I thought it'd be really neat to take a poetry break here. And poetry, of course, you can read the poem, but it doesn't really come alive until you like read it out loud. So just showing you that poem probably doesn't mean too much. So let's get Poetry Cow up here. Dun, dun, dun. It's Poetry Cow. All right. And this poem happens to be a limerick, but it's a sophisticated limerick, so I kind of like this. All right, so here we go. A dozen, a gross, and a score, plus 3 times the square root of 4, divided by 7, plus 5 times 11 is 9 squared and not a bit more. Isn't that a nice poem? A dozen, a gross, and a score, plus 3 times the square root of 4, divided by 7 plus 5 times 11 is 9 squared and not a bit more. Wonderful poem. Okay, that's just good. It's just in the mood. Let's go do some logarithms. So we've looked at a lot of bases, but there are 2 bases that are used most often, and we've not talked about either one of them so far. One of them is pretty obvious. It's base 10, right? Most everything that we do in life, we use base 10. And so, if the exponential form looks like this, then the logarithmic form looks like this. And you're like, wait a minute, where's the base? How come it doesn't say log base 10? Yep, here come those lazy mathematicians again. Right? We know what happens with square root, right? Mathematicians get so lazy with square root that we don't bother putting that little 2 where it should be. Same thing with logarithms, right? Any other base, we show what base it is, but base 10, we get so lazy, we just put log, right? Just like we don't put that little 2 for the square root symbol, we don't put the 10 for log base 10, right? Mathematicians are famously lazy at times. So what's the other special number? Well, why do we use base 10? Almost every culture on the history of this planet has used base 10 because they count on their fingers. Now, a few cultures developed using base 20. Yeah, you guessed it, 10 fingers, 10 toes. And there are a couple other really bizarre examples out there, but almost every single culture on the history of this planet developed a base 10 numbering system. Now, Mother Nature, of course, uses base E, right? We have 10 fingers. Mother Nature has E fingers. So base 10, we call that the common logarithm, and we just put log. Base E, however, we call that the natural logarithm, right? Here comes Mother Nature with her E fingers. And notice instead of putting log base E, we put a little ln. Say, oh yeah, we're using a logarithm, but we're using the natural logarithm. Right? So instead of log base 10, we just write log. Instead of log base E, we just put ln. Believe it or not, most calculators, you can find those buttons quite easily. Notice that the log button, if you look carefully, the secondary feature is 10 to the x power. And if you look at the ln button for natural log, the secondary feature is the e to the x button, right? And so most calculators, you'll find those buttons quite readily. Sometimes you have to go into one of the menus to find those. But most scientific calculators, you've got log and natural log right at your fingertips, just like most of them will have sine, cosine, and tangent right there ready to punch on. right? So base 10 and base E, it's almost a given that a scientific calculator is going to have those readily available. So we can rewrite in exponential form. So if I see log 1000 equals 3, oh, well, the base must be 10 because I just see log. So yeah, 10 to the third power is 1000. Now, the problem with E is such an absolutely weird number that we're just not going to be able to use the equal sign. So you're going to see this approximate equal and say, okay, if I use the natural log, I know it's log base E. So the base is E, the exponent's 4, and I know E to the fourth power is about 54.598. Natural log, again, I say, okay, the base is E, exponent's at -1, E to the -1 equals 1 over E. We can also go the opposite direction. We can start with the exponent. Hey, 10 to the fourth power is 10,000. So I need log base 10. Like I'm going to write log base 10. I'm just going to put log. All right? I'm not going to put log base 10. Also just put log. 10,000 equals 4. And I should probably take a time out here and talk about logarithms. When you hear about, oh yeah, there was an earthquake and it was a magnitude 4. This is what's going on. Right? They're using logarithms. Right? So they say, hey, an earthquake of 5 is 10 times as strong as an earthquake of 4. Well, this is why it's 10 times as strong, right? They're using a base 10 logarithm. Or in the old-fashioned days, when you were using an SLR camera, you had to actually put film in there, and you had to focus and take pictures, and you had to develop the film. Well, anyway, there would be an f-stop setting. So there'd be a little dial you'd turn around on that camera. So besides focusing, you'd also set the film speeds. Those f-stops were logarithms, right? E raised to the pi power is about 23.141. Okay, I got to do log base E. Of course, I'm not going to write log base E. I'm going to put ln, right? ln means log base 3. So natural log of 23.141 is approximately equal to pi. E to the 0 power equals 1. Well, that makes sense, right? Any number to the 0 power is 1. So log base E, but I'm not going to write it that way. I'm going to write natural log. But, you know, log base E of 1 is 0. Or in other words, natural log of 1 is 0. And then, of course, we can play this game, which is pretty much similar to the game we played previous lesson. Right? We're just kind of reinforcing, hey, what's going on here? If x to the fifth power is 243, what number are we talking about? And maybe you can do this stuff quickly in your head. Maybe you look at the exponent table and say, oh, it must be 3 to the fifth power. X is just going to be 2. That's supposed to be a 3. That should say x equals 3. I got to fix that. Pretend it says x equals 3. Let's see if I got any other goof ups. If I got any more goof ups, I'm going to have to erase this and start over. Just plain old log means 10. So 10 to the fifth power is x. So 100,000. Please have x equals 100,000 in there. Yay, yay. Okay. So I just have the one typo I got to go back and fix. Log of 100 equals x. So let me see. The base is 10, right? Because this is log. Exponent's x. So 10 to some power is 100. That must be 2, right? 10 squared is 100. X must be 2. It's embarrassing. But, oh, actually, I can fix it. I can fix it like this. All right, I'll go back and retype it better. But for our purpose, I fixed that one. So, it's time for a worksheet. Dun, 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 dun. Now, I don't know why, but these graphics just kind of remind me of a disco ball. Don't ask me why, just kind of a weird association.